Hello, welcome to this lesson on phase changes. What are the 6 phase changes? Phase changes can be caused by either the addition or the removal of both heat or pressure. So here we have a solid, here's a liquid, and here is a gas. And by adding or removing heat, we can change between phases, but we can also do that by a change in pressure. We're going to rapid fire through the phase changes. Anytime we are converting a solid into a liquid, we call that melting. The reverse, liquid to solid, is freezing. Going from a liquid to a gas or vapor is called vaporization. And going from a vapor or a gas to a liquid is called condensation. Now, these first 4, I'm sure you know, because you experience these pretty much all the time in your everyday life. If you were to take ice cubes out of the freezer and let them sit on your counter where there is more warmth, they are going to melt into a liquid. If you allow that puddle to sit, eventually it will evaporate, which is like a slow version of vaporization. You can heat it up by, speed it up rather by heating it up. So you can boil, that's a vaporization. You can take moisture that's in the air. If you have ever had a really cold glass of water on a hot, humid summer day, the water vapor from the air will come in contact with the cold glass and it will condense right there on the glass. And that's when your glass, we say it sweats. It's kind of a gross way to describe it, but that's what we say. And then anytime you take that liquid, make some ice cubes, popsicles, put them in the freezer, removal of heat, they are going to become solid. We can also do the same thing with a change in pressure, and that might be new. If you take a gas, and if you think of a particle diagram, and then you squeeze all those gas particles together, i.e. you put them under a lot of pressure, eventually those particles will be close enough together that they can become a liquid. And the same is true of liquids. We don't do this very often, but you could. You take a liquid and you squeeze the particles close enough together, you can make a solid. The reverse is true as well. If you have a solid and you remove a lot of the atmospheric pressure, which typically we're going to need something fancy like a bell jar in order to do that, and a vacuum pump, remove enough of that pressure and the solid particles don't really feel the need to be that close together, and they will melt out into a liquid. You do the same thing to a liquid. Those particles are able to spread even further out into a vapor. You may see the release of pressure on a liquid resulting in a gas if you have any type of like compressed gas, like keyboard cleaner. Keyboard cleaner a lot of the time is compressed, so there's a liquid inside of that container. And then when you press the button, you are allowing that to come out into the atmosphere, which is a low pressure situation compared to the tightness of the bottle or the can. And in that case, the liquid is going to vaporize because it has less pressure on it, and then it'll be a gas. Now, this one might be a little bit new. If you have a solid, you skip over liquid and go all the way to a vapor. That is called sublimation. If you have ever experienced dry ice, then you know what a sublimation looks like. We call it dry ice because it is a solid. It skips over liquid and goes straight to gas. A lot of the time you can get dry ice at a grocery store, but you absolutely probably will get it if you order groceries. And I mean like from the internet and they're going to be shipped. If you order like a meal prep kit, a lot of the time those things do come frozen with dry ice because dry ice won't make your groceries all soggy, where water ice will do that. It's really fun to play with. It's not super safe for your bare skin, so it's good to use like salad tongs or an oven mitt to manipulate it, but it is a lot of fun when you get it. It's this white looking ice cube and it vaporizes. I like to, anytime I get a grocery delivery of that nature where I have dry ice, I take it and I put it in a sink full of warm water to kind of let it out. It's just carbon dioxide that's been frozen. Sublimation does happen in your everyday life, maybe not every day, in your winter life, maybe, depending on where you live. If you Ever see the big piles of snow that get kind of plowed? Usually it's in parking lots where they plow the entire parking lot and they make these giant piles of snow. Some of that snow is going to go like standard melting. It's going to go from solid, it's going to turn into a liquid, and you'll have a puddle underneath. But the entire pile of snow will not melt down into a puddle. Some of it will sublime. It will go from solid, it skips over liquid, and it just goes straight to the vapor. It kind of evaporates off of that big pile of snow. The opposite of sublimation is called deposition, and that is where a vapor is going to skip over liquid and become a solid. This is frost in your real life. If you've ever woken up early in the morning to frosty grass or frost on maybe your car, that is from water vapor in the air coming in contact with the cold blade of grass or the cold car, the surface of the car, and it is going to be so cold that it can skip over the liquid and immediately become a solid. Energy is defined as the ability to do work, and we measure that in joules, Joules, and the unit for that is just the capital J. Joule is a metric unit, so we can stick prefixes on it to give a relative size. This definition of energy is a little tough to understand, the ability to do work. What exactly does that mean? It really means anything that is not matter. You have energy in your body. That's what keeps you alive. That's what's able to move your muscles. Movement is kinetic energy. Warmth or heat is thermal energy. The energy that's stored in food in its chemical bonds is called chemical energy. If it's not matter, then it's energy. When we talk about phase changes specifically, we talk about both kinetic and potential energy. And in your middle school science classes, you've probably learned about kinetic and potential as movement and stored energy, which is true. But when we talk about it in terms of molecules, the definition is the same, but a little bit more specific. Kinetic energy is really molecular or particle motion. So we relate that to how fast the particles move, and that is related to their temperature. The faster particles move, the more kinetic energy they have, and the higher their temperature. Hot particles move faster than cold particles. Here you have kind of these little motion lines that are showing you that the hot particles move kind of quickly and your cold particles don't have lines because they are, not that they're not moving, it's just that they're moving so slow they don't need action lines. Potential energy is kind of more so related to holding particles together. It's kind of similar to their intermolecular force. Gases have more potential energy than solids because they are further apart. Anytime a phase change is occurring, there is a change in potential energy. If your substance is going from solid to liquid or liquid to gas, so on the diagram that we had from solid toward gas, then you are going to have an increase in potential energy. And if you're going from gas to liquid, gas to solid, or liquid to solid, from right to left on our diagram, then you would have a decrease in potential energy. So again, anytime there is a phase change, you are changing the amount of potential energy in your sample. If we needed to figure out the amount of potential energy being lost or gained as a substance changes phase, we have two equations. We have an equation anytime we are converting from solid to liquid or liquid to solid. And to do that, we would use the heat of fusion. Here's the equation, Q equals MHF. Q is the heat that is measured in joules. If you are given a value in kilojoules or you're asked for kilojoules, joules fits into the metric base unit, and you'd have to go from joules to kilojoules. You would move your decimal 3 times to the left. Kilojoules to joules is 3 times to the right. M is the mass of your sample measured in grams, and then H sub F. HF is really the heat of fusion. It's one term. The F is just here to describe the H, the type of heat, and the heat of fusion is a constant. It is going to depend on the particular substance that you're working with. It's always measured in joules per gram because heat in this equation is joules and mass in this equation is grams. The heat of fusion for water is 334 joules per gram. Anytime we convert between a liquid and a gas, we would use the heat of vaporization equation. So it's really the same thing. Q stands for heat in joules, M is for mass in grams, and then here instead of HF, we have HV, which is the heat of vaporization. Again, that's a single term. That little v is just used to describe the type of heat, and that is the heat of vaporization. Again, the units are joules per gram. And the heat of vaporization for water is 2,260 joules per gram. In these types of problems, you will be looking for keywords such as a sample boils. That's how you would know to use Q equals mHV. If a substance is freezing or melting, then you would know to use Q equals mHF. You got to look for the keywords to know which equation to use, and then you just plug it in and solve it like it's algebra. It is important to be mindful of your units. Remember, joules is a metric unit, so you may need to convert using the metric conversions into kilojoules or out of kilojoules. And same with mass. A lot of the time, you will measure water in kilograms, especially if you're boiling like a whole pot of water. So please be mindful of your units. That is all for this video. Please make sure to comment any questions you have below the video, subscribe so you don't miss the next lesson, and I'll see you there. Bye.